Hello and welcome to the podcast for Math 3A. I'm Greg Perkins. I will be your host. This first problem gives us this function, which is going to be the height of a rock after it was thrown in the air. This plus 6 means that as the person released the rock, it was 6 feet off the ground. Then it would go flying up into the air, gravity would take over, bring it back down, and eventually it would hit the ground. So this axis down at the bottom is going to be time t. Now down here, I'm not quite sure what the numbers are supposed to be. So what I could do is use this little formula. Negative b over 2a, which is a piece of the quadratic formula. So if you look at this is a, b, and c, then do this little formula. It's going to be negative 40 divided by 2 times negative 16. The negatives are going to cancel out, and then we would have 40 divided by 32. So it takes 1 1/4 seconds, and that is where the vertex is. So it would reach the highest point after 1 1/4 seconds. Okay, then on to Part A. Find the average velocity. Well, of course, distance equals rate times time. Or if you need to solve for rate, or in other words, velocity, divide both sides by t, and distance divided by time is rate. Now for the distance, what we need to do is take a 1 and substitute it in. So 1 would be approximately right here. Substitute it in and find out the height of the rock. Take a 2, substitute it in, and find out the height of the rock there. And if you subtract those two heights, that's going to be the distance. If you subtract these two times, that's going to be the time. Or in other words, substitute 2 into the function to find the height, substitute 1 into the function to find the height, and then subtract those to find out how far it traveled during that second. And then subtract 2 minus 1 on the bottom, and then this is going to be distance divided by time. So then substitute 2 into the function. So substituting a 2 for t, that'll be negative 16 times 2 squared plus 40 times 2 plus 6 minus, and it's important to put a parenthesis right here because this minus applies to everything after it. So minus, when you substitute a 1, that's just going to be 1 squared is 1. That's just going to be 40 times 1. So inside the parentheses there's negative 16 plus 40 plus 6. And then it gets divided by 2 minus 1, or 1. So then how much is this? So I'll do this part first. Negative 16 times 2 squared is 4, plus 80 plus 6. So that is the 2 seconds. So at that moment right there, that red dot represents 22 feet off the ground, minus a negative 16 plus a 40 plus a 6. So at this moment in time, that red dot represents 30 feet off the ground. And then when you subtract, it's going to be negative 8, and the units are feet over seconds, or we usually call it feet per second. So as it went from this red dot to that red dot, it's going down. So of course it's going down from here to here, and that's what the negative represents. The negative means that it's going down. Now when you have 2 red dots like this, and then you draw the straight line through those dots, that's called a secant line. And what we just found is the slope of the secant line. Then for part B, so estimate the velocity as the rock hits the ground. So that means this moment right here is when it hits the ground. So we need to solve for t. Well, if it's on the ground, that means the height equals 0. So substitute a 0 right here, and then we're going to do the quadratic formula. So this was part A, and now here is part B. So 0 equals negative 16t squared plus 40t plus 6. And then for the quadratic formula, so negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times the a. And then calculate that. So there's a negative 40, and then now there's going to be a positive answer, and if it could go back in time, there would be a negative answer. But I only want the positive answer. Well, this is going to be negative, and this is going to be negative, and if we also use negative, then it'll be negative on top divided by negative on bottom, and then it'll be positive. So actually I only need the minus square root. So minus the square root, 40 gets squared, and then right here a negative negative will make positive. 4 times 16 times 6, and then put the numerator in parentheses, and it's divided by negative 32. A 2.6. So if this is 2.6 right here, that makes sense. So t equals 2.642. Now what I need to do is this idea, except instead of using 1 and 2, I need to use two numbers that are very close to this. So then I'm going to use t equals 2.6 and t equals 2.642. So in other words, right before it hit the ground and then right when it hit the ground. So the two red dots would be right here, very close to each other, and that'll give a good estimate for the velocity. So now we just repeat what we did right here. So we're going to do h of 2.642 minus h of 2.6, and that's divided by 2.642 minus 2.6. This right here is called the difference quotient. So quotient just means you have a fraction, and because we're doing the difference, it's called the difference quotient. Okay, anyway, so I could type those in the calculator like I usually do, or I could graph it. So go to y equals, and then put the original function, negative 16 x squared. So right here the calculator prefers to use x instead of t, but that's all right. Plus 40x plus 6. And then go to the window, and the x's, so it starts at 0, and then it lands at 2.6. So I'm just going to put 3, make it a little bit bigger so I can see when it lands. And then I don't know how far in the air it goes. 50? Well, that seems like a decent guess. I'll just see. Does that work? Take a look at the graph, and actually that was a pretty decent guess. All right. Now plug in the 2.642. So trace, and then start typing 2.642, and the height, that should actually say 0, because that's when it landed on the ground. But we had a little bit of rounding error when we did the quadratic formula, because this is probably 2.641516, something like that. So there's a little bit of rounding error, but that's okay because this is an estimate anyway. So negative 0.03, and then substitute the 2.6. So then it's minus 1.84. And then when you subtract these two, the 2.6 is going to get canceled. So what it leaves is 0.042. Then how much is that? So this is a good opportunity to learn something about the calculator. When I write this, it means negative. And when I write this, it means subtract. So we write them exactly the same, although they mean two different things. Well, the calculator will get confused if you don't tell it which one you're talking about. So this is the negative 0.003, and then this one is subtract 1.84. And then put that in parentheses so the calculator knows all of that gets divided by 0.042. And then it's negative 43.881, and this would be in feet per second. So the negative means that it's going down, so it'd be going down at approximately 43.881 feet per second.